Hi there, my name is Rob Rizzini, and I'm with the Intel's America's Channels organization. And I'm here at the unveiling of our new Robotics Innovation Lab in Ashland, Virginia. Built in conjunction with Intel Partner Alliance and the America's Channels organization, partnered with Bluestar and many vendors in our ecosystem. We're pleased to offer this innovation center as a place to collaborate with end users, channel partners, and of course, our hardware vendors to solve industry problems with robotics and emerging technologies. This showcase center takes clients and partners alike through the history of robotics and Intel's innovations all the way back to our first microchip. In fact, when you walk through this lab, you'll see examples of robots that are right involved in the heart of robotics environments. So let's take a quick walk through and see some of those robots as we walk over. In fact, let's go right over here to the CyberVac. Well, robotics isn't new. In fact, the problems that we've been trying to solve with robots for the longest time have been at the heart of labor challenges all the way back to the early 80s. In this example, we have one of the world's first floor cleaning robot, powered by an Intel 386 processor. The concept behind this was effectively a prototype going after taking a desktop computer and aligning it into a fully autonomous system for cleaning robots. Now, it's not leveraging AI in the ways that we think about things today, and had very fixed function capabilities and routes that had to be hardwired into the system. But the power of this from a vision standpoint is what set the tone for where robots have continued to evolve, throughout the generations, including what we're building now with Panther Lake. When you visit the TECNEXUS in Ashland, Virginia, accelerated by Intel, of course, you have the opportunity to talk to your clients about the role that robotics has played throughout the evolution of technology. In fact, as you take a walk through the museum, what you'll see is examples of industry problems that we've been dealing with in robotics for a long time. From the first scrubbing robot to floor vacuuming. When you look at the role that Intel has played in evolving and developing the first retail and hospitality robots, when you dig into the applications for security, Intel Robotics has been engaged all the way back to the beginning. And that's really the story that we try to tell here at the Innovation Lab. Because it's not just about understanding where you can go, it's about understanding the path that we've been on in the past. Well, now that you come to the lab and learn about the history, now what we want to do is delve into what's capable today and how are the technologies enabling us to do new things. And that's what the Intel Innovation Booth is all about. We're showing off hardware capabilities from our key edge partners and talking about the power of our underlying technologies, including our leading capabilities with Panther Lake. In fact, let's just dig in and show it to you. Well, walking into the world of microchips and how they've helped us evolve the world of robotics starts all the way back in the 1980s with the Intel 8008 8-bit processor. What we've done throughout the exhibit is talked about how the technology has evolved over the decades and enable us to now get to the current generations of technologies, now including the capabilities of the Intel Core Ultra to drive an integrated capability that enables true edge performance for robotics without expensive external GPUs. No conversation about Intel's capabilities would be complete without a walk through the Intel fab. And we've made sure to highlight our friends in the factory who are there building the best world-class technologies. And we're showcasing the capabilities of Intel Foundry, including our latest packaging technologies, and of course, all of the robust power to generate the most sophisticated supply chain in the world for semiconductors. So when you're coming in and talking about robotics with your end user, channel partner, or even your existing solution builder, what you're emphasizing is the way that Intel can be a trusted partner in embedded compute for decades to come. Robotics is an edge application. It's all about applying compute right where the real world action happens, whether that's in retail, hospitality, healthcare, or in a warehouse. This small edge server provided by our partner Lenovo, in this case talking about how much power we can put into a small environment for building up AI agents or the full intelligence that is required for training the models to navigate a space just like this. These kinds of form factors we love to highlight from our hardware partners. And if you're in the midst of building a design, showing your partner that we're prepared to help them scale it here at the Innovation Lab is a great value prop to be sharing with your customer. As we move along, of course, robots require computes to be literally inside. And if you walk through the History Museum, you saw effectively a 386 desktop computer sitting on top. And look at how small and clean it can be with hardware from partners like ASUS or Unlogic, put into dust-proof capabilities and offered in a way that can be embedded in all sorts of interesting ways. But the edge isn't just about what runs on the robot. It's also about the intersection of the people that are involved with robotics and those robots moving around to space. And that's why we're able to highlight things like mobile devices built on our Core Ultra 3 series processor, in fact, running Android from our partner Zebra. These environments allow the management of robots and the visibility throughout a space of what kinds of things they're doing. Think about the ways that you can drive innovative conversations with your channel partner or with your end user here at the Ashland Lab. The last form factor that we really think about is the ways that groups of robots and humans have to collaborate in ways where they're accessing the same kinds of information. And that's where looking at things like smart displays with built-in capabilities for compute that can share data and control different areas. This enables effectively work cell environments, probably most evidenced by things like the robotic arm, which you'll see working in factories all around the world. Let's see how this one works. Wow, that's great. So what do we have going on? We have a robot being controlled in the background by an Intel-capable edge device, and in this case, monitoring data feeds coming off of RealSense 3D cameras to help us know when that ball is being dropped, which cell it's going to be falling out of. Now, what's neat about this inside of the lab is we're integrating this with our digital twin technologies, so that when you walk through the environment with your customer, you're going to actually have a full simulation of the space, showing off the capabilities of Intel's platforms for digital twin. The ideas and demos that you see here aren't just theoretical. Let's take a walk and take a look at the kinds of robots that are in real production today that your customers can experience. Well, when we think about robotics, of course, the cool thing people think about is humanoids. But in autonomous mobile robotics, what we have to understand is that the robot is built around the form problems that they're dealing with. So we've seen the robots that are trying to serve us sodas, but we also have robots that are carrying pallets. We have robots that are designed and focused on solving industry-specific problems. In healthcare, we end up with many applications where we need to be able to secure content specific to a hospital's needs, like drugs and medication that have to be operated in a controlled environment. And we've all been at the restaurant that has the service robot delivering tables. Or maybe you've walked through a college campus and have seen a robot, running along delivering sandwiches. These are the kinds of form factors that get delivered to our clients in the real world. Clients in the hospitality industry don't have to be waiting for the next humanoid robot to get stuff done. These are in production today at companies like Marriott. But the thing that makes this different is that the robots that we're showing are actually controlled through a robotics operating platform. So instead of thinking about one single robot to solve a problem, we can talk about different form factors in different locations, all managed by one spatial intelligence platform controlling all the different robots. This open standards-based approach can be a mechanism for you to solve customer problems specific to their industry area, yet still have full management capabilities of the kinds of information coming off those robots. This is the kind of innovation that you can drive with your clients if you bring them to the TECNEXUS lab in Ashland, Virginia.